Today we're embarking on a fascinating journey to explore something we all experience but rarely think about, the Earth's rotation. Imagine this. Our planet is like a giant spinning top turning on its axis, an imaginary line that runs from the North Pole to the South Pole. This spinning, known as Earth's rotation, takes about 24 hours to complete one full turn, and it's responsible for one of the most basic cycles of life, day and night. But wait! You might wonder, if the Earth is spinning so fast, why don't we feel it? Great question! Let me take you on a deeper dive into this mystery. At the equator, where the Earth's belly bulges out, the surface speed is a whopping 1,600 kilometers per hour. That's about 1,000 miles per hour. Yet we go about our daily lives without ever noticing this incredible speed. How is that possible? Well, it all comes down to something we've experienced during other forms of travel. Imagine you're in a car cruising down the highway at a steady pace. After a while, you stop noticing the speed. You're moving at the same rate as everything around you. The same thing happens with Earth's rotation. Because everything, buildings, trees, you and me, is moving together at this constant speed, it feels as if we're standing still. Another reason we don't feel this motion is related to something called centrifugal force. This is the outward push you feel when you spin around in a circle. However, on Earth, this force is much weaker compared to the pull of gravity that keeps us firmly planted on the ground. Even at the equator, where the centrifugal force is strongest, it's only a tiny fraction of Earth's gravity, about 1/300th to be exact. This is why we don't float away or feel dizzy from Earth's spin. We're held tight by gravity. Now let's talk about how this rotation creates the day and night cycle. As the Earth spins from west to east, different parts of the planet move into and out of sunlight. When your part of the Earth faces the sun, it's daytime. As it spins away from the sun, night falls. Simple, yet so profoundly important for life as we know it. This spinning also makes the stars appear to dance across the night sky. If you've ever noticed the stars seem to move from east to west over the course of the night, you're witnessing what's called diurnal motion. It's not the stars that are moving, but the Earth beneath you spinning on its axis. And here's something even cooler. Our planet's rotation affects how things move in a way that's visible from space. Artificial satellites, those man-made objects orbiting Earth, don't move in perfect circles, but are slightly tilted westward. This happens because of the Earth's spin interacting with the satellite's movement, a reminder of how dynamic and interconnected everything in our universe is. Now let's introduce you to a historical experiment that made Earth's rotation visible, the Foucault pendulum. Picture this, a giant pendulum, just a heavy weight hanging on a long string swinging back and forth. In 1851, French scientist Léon Foucault set up such a pendulum in Paris. As it swung, people could see the direction of its swing slowly changing over time, not because the pendulum was moving on its own, but because the Earth was rotating beneath it. In the northern hemisphere, this swing direction rotates clockwise, a simple yet profound demonstration of Earth's spin. Another fascinating effect of Earth's rotation is something called the Coriolis effect. This is why if you threw a ball straight up in the air on a spinning planet, it would actually land a little to the side. In real life, this effect is most noticeable in how it influences the wind and ocean currents. In the northern hemisphere, moving objects like air currents are deflected to the right, and in the southern hemisphere they're deflected to the left. This deflection shapes weather patterns and ocean currents, playing a crucial role in our climate. But Earth's rotation isn't perfectly steady. Various forces cause tiny changes over time. For instance, the gravitational pull of the moon creates tides, which in turn create friction that gradually slows down Earth's rotation. This effect is so small that it only lengthens the day by about 0.001 seconds per century. But over thousands of years, this adds up. Earthquakes can also cause abrupt changes in rotation speed by redistributing the planet's mass, just like a figure skater pulling in their arms to spin faster. One of the most important consequences of Earth's rotation is the creation of our seasons. Our planet's axis isn't straight up and down, but tilted at about 23.5 degrees. As Earth orbits the Sun, this tilt means that different parts of the world receive varying amounts of sunlight throughout the year, leading to the changing seasons. When the northern hemisphere tilts toward the sun, it's summer there. When it tilts away, it's winter. Let's also talk a bit about how this rotation is connected to our timekeeping. Our concept of a day, 24 hours, is based on the time it takes for Earth to complete one full rotation. But because Earth's rotation isn't perfectly steady, scientists occasionally add a leap second to our clocks to keep them in sync with the actual length of a day. This helps ensure that our timekeeping stays accurate in relation to the sun. So, next time you watch the sunset or gaze at the stars, remember that these daily and nightly rhythms are all thanks to our planet's steady, reliable spin. Earth's rotation is a fundamental part of what makes life on our planet so beautifully predictable and yet endlessly fascinating. It connects us to the universe in ways we might not always see but are always there, spinning along with us.